Hey guys, we're going to get right back into the episode, but before we do, I want to let you know about Anchor, the easiest way to make a podcast happen. It's everything you need, and it's all for free. It has creation tools, sample sounds, easy distribution to platforms such as Spotify and Apple Podcasts, and even ways to make some money on the side. Before I started podcasting, I didn't know about Anchor, and when I got it, I realized it's very easy to make a podcast. So if you're interested in podcasting, download the free Anchor app or go to anchor.fm to get started. Now let's tune back into the episode. Bitcoin introduced electronic money that isn't touched by any third parties. No government, no intermediate banks, just your money. All thanks to something called a blockchain. Using the same blockchain technology, a platform called Ethereum made it so that we can create any arbitrary decentralized application. On Ethereum, I could transfer ownership of my house to my friend without having to go through any third-party intermediaries. Well, what if we took this principle to an even higher level? What if we decentralized the internet? In practice, the internet seems decentralized. You type in URLs in your favorite browser's address bar and content magically appears. Maybe an ebook or web game. But who owns this digital content? Well, for an ebook, an author, right? But what steps did the author have to go through in order to host their book online? Well, they had to contact some company, Amazon for example, and Amazon would host their book on their servers, allowing everyone to buy it. So does the author truly own the book? Or is the book owned by Amazon's servers? And what's stopping someone from redistributing multiple copies of the book on their own website once they've bought the book from Amazon? This problem may seem daunting, but people are actively working on solving it. Today, we read the Elastos Whitepaper, which outlines exactly how this problem can be solved. This is the Whitepaper Center, brought to you by Randall Richard Raymond. The authors begin by explaining the technology that came before Elastos, namely Bitcoin and Ethereum. Bitcoin brought us the blockchain, a data structure that keeps track of transactions. In Bitcoin's case, those are monetary transactions. Ethereum brought us smart contracts on top of the blockchain. Besides sending transactions to other users, transactions could be sent to activate digital programs that could do a large assortment of things. One might think that these smart contracts could be used to create any conceivable decentralized application. However, the authors argue the contrary, primarily due to a number of limitations that they say are inherent in Ethereum. On Ethereum, all data is stored on the blockchain. Applications that require a lot of space quickly congest the blockchain. Furthermore, the authors argue that there is a high degree of inflexibility with blockchains such as Ethereum. This includes the difficulty of reversing bugs in smart contracts, as well as the demanding fees of running so many transactions. On top of that, the authors argue that a blockchain speed is a blockchain speed. Using a decentralized app on a highly performant computer or mobile device won't change the experience of interacting with an app based on Ethereum. This all leads into the motivation of the author's new blockchain, a blockchain called Elastos. Instead of making all transactions and all decentralized apps run on a blockchain, Elastos mainly uses the blockchain to authenticate traffic over the internet. As a result, apps can run separately in a sandbox environment and communicate back to the network using the blockchain. This is a paradigm shift, but an important one. Instead of using the blockchain to run apps, Elastos wants to use the blockchain to support apps. Okay, so some of this all might seem very abstract, so let's try to make things a little bit more concrete. To do that, let's explain some of the fundamentals of the internet. And in order to understand the internet, let's talk about something familiar, the postal system. We use the postal system to deliver physical items around the world. Similarly, the internet is used to deliver digital information around the world. The postal system seems complicated at first, but it is just a system of communication standards to move an item from point A to point B. With the internet, these communication standards are called protocols, and they exist on 5 layers. The first layer is the physical layer. This is where the language of computers, ones and zeros, are converted into electrical, radio, or optical signals and transmitted using some sort of hardware. This is similar to USPS using a plane to get your mail from country A to country B. Once your digital information has passed through the physical medium, it's handled on layer 2, the data link layer. The data link layer grabs the raw bits from the electrical wire, packages these bits, and sends them up to the next layer. Imagine the USPS plane has landed and workers come and grab the packages in the plane, bundle them together, and ship them off to the post office closest to the package's destination. That's another way of looking at the data link layer. Layer 3 is a lot like the post office. It receives information from layer 2 and routes these packages to an address. Once the package reaches a building, it still needs to be sent to the right room in the building. The building is like a computer. The room that the package needs to be sent to is a program running inside of the computer. The room number is the port. At layer 4, messages are routed to the appropriate program running within a computer using something called a port, which is just a number that tells us what program in a computer to go to. Layer 5, the application layer, is analogous to a person physically receiving their mail. That person should know how to interpret that mail. Similarly, on the application level, computer programs adopt protocols for responding to and interpreting messages. One of the most famous application level protocols is HTTP, which you see all the time in your web browser address bar. So, a while back, Rong Chen, a senior software engineer at Microsoft, came up with the idea of preventing applications from directly accessing the internet. Put in other words, in order to send mail, you'd have to go through a secure channel. In 2017, this vision was combined with blockchain technology such that a blockchain is a part of this secure channel. A blockchain would serve as the backbone of a new internet. The authors call this internet the Elastos Smart Web. The Elastos Smart Web is composed of 4 parts: the Elastos blockchain, the Elastos runtime, the Elastos carrier, and the Elastos software development kit. The Elastos blockchain registers a unique ID for every entity on the smart web, every user, and every device. It's used to record very basic transactions on the web. The Elastos runtime lives on your computer or mobile phone. It's like a virtual operating system that prevents your computer from directly accessing the internet. Going back to our analogy, the runtime will make sure it's double checked with the blockchain before sending any mail out. Next, the carrier is a network layer that exists on top of the 5-layer architecture of the internet. It ensures that traffic can be sent directly from computer to computer without having to go through big servers owned by companies like Amazon. Finally, the Elastos software development kit is something that application developers use. It allows apps to communicate with the more technical stuff associated with Elastos blockchain and the Elastos carrier. We'll get into each one of these 4 pillars in more depth as we continue the reading. However, keep in mind an important understanding. Elastos is using the blockchain in order to make content on the internet authenticated and scarce. Instead of sending packages containing your favorite book to all of your friends and acquaintances freely, you must go through a secure channel that makes sure you own that book and that you're sending a legal number of those books. So the first of 4 fundamentals that we'll explore more is the Elastos blockchain. This is the most complicated of the 4, so I encourage you to rewind as necessary. Also, keep in mind that what we discuss here is based on the contents of this white paper. Things have changed since this white paper's publication, including Elastos' move towards delegated proof of stake, which is what we talked about last episode with EOS. However, this will all be discussed in a later episode. So, back to this white paper, the basic structure of the Elastos blockchain is very similar to the original design for the Bitcoin blockchain. Nodes would compete to solve a cryptographic puzzle. The winner would link the new block to a previous one, extending the chain. However, Elastos introduced the idea of sidechains, essentially blockchains that extend off the main chain and are responsible for running transactions for decentralized apps. More on this later. So, the Elastos blockchain is also merge mined on top of the Bitcoin blockchain. What exactly does merge mined mean? Well, recall that proof of work is a race to determine who will add to the next block. Elastos employs a similar scheme. There's only one problem though. What if no one wants to contribute to this race? Contributing to the proof of work race requires spending electricity. So people might only want to work on the Bitcoin blockchain. To respond to this, Elastos uses merge mining, which basically means the work you do to win the Bitcoin proof of work race can count towards the race you do to win the Elastos proof of work race. Not only does this save energy, but you can also make money on both the Bitcoin blockchain and the Elastos blockchain, and maintain security for both chains. The basic unit of currency in the Elastos blockchain is something called ELA. This token is analogous to the Bitcoin in the Bitcoin blockchain. The authors state that they aim to reach an inflation goal of 4% per year. Now, let's revisit sidechain, Elastos' original vision for scalability. The idea is that extremely important transactions happen on the main blockchain. Everything else, including most services and apps, take place on their own sidechains. Transactions can be sent from the main chain to the side chains, as well as from the side chains to the main chain. On top of that, smart contracts are typically delegated to these side chains. Put all together, someone might want to read an ebook. They would invoke a transaction on the main chain that delegates to a side chain, which is dedicated to a book reading app. That side chain would ensure that the user has access to the book, and if so, would ultimately allow network traffic to go through, giving the user access to the book. Next up, we have the Elastos carrier, which is a network layer that exists on top of the 5-layer internet model. This network layer exists as a peer-to-peer network. This is in stark contrast to a client-server network. In a client-server network, I have to go through some middleman in order to get my mail sent to my friend Bob. In a peer-to-peer network, I can send my mail directly to Bob. This infrastructure makes it such that mail can only be sent based on the authentication from the blockchain and nothing else. The Elastos runtime and the Elastos software development kit are the house and the tools of decentralized apps. The runtime provides a layer over your operating system that ensures that communication over the internet is authenticated via the blockchain. Normally, apps access low-level technology on your computer that allow them to send messages across the internet. No authentication happens. As long as the app knows the right internet address to talk to, then all is set. With the runtime, apps need to ensure their messages are legal. The software development kit provides apps with the programming they need to talk to the blockchain in the Elastos carrier. So it's important to note the brains behind this project. First and foremost is Rong Chen, the founder of Elastos and a former senior software engineer at Microsoft. He started working on Elastos all the way back in 2000, before blockchain technology was ever in the vision. Today, Elastos is maintained and supported by the Elastos Foundation. The authors express that the Elastos community includes a wide and diverse group of people, all doing their best to bring up the Elastos vision. Today, we've done a guided reading of Elastos, a project that seeks to make the internet safer and more secure, a project that wants to give people ownership and power over the data they distribute over the internet. Elastos has proven itself to be an ambitious project, but it's a project that many people believe in. The ultimate goal, as they put it, to change the internet from a web of information to a web of wealth. And that's all we have for you today. In our next episode, we'll be doing a guided reading of Sergey Popov's white paper titled IOTA, The Tangle. See you next time.